Any any skill sounds easy for a few days. After some time, then you start feeling difficult. So, in fact, every skill more or less the same. A lot of people think this is difficult skill, this is this one easy skill. It is not like that. In fact, easy skill means there will be too many people. Building career in easy skill is difficult. Manasa, please note this point.
Yes, Srini.
Building skill in the easy skill is difficult. Building career in easy skill is difficult. Why? Because there will be too many people. Building career in difficult skill is easy. Why? Because there will be less people. Because the building career in difficult skill only needs effort, support system, being with the right
Practice.
mentors. That sounds counterintuitive, right? Hey, Indra, difficult skill easy entered in the not. It sounds counterintuitive. Go into research. So, but the difficult skill becomes easy if you have right mentors. So that's where Harun and we come into the picture. We have a lot of experience, not only doing the projects, guiding you. So once you have right mentors, it will be easy. It will be easy. But so first thing is a lot of people don't come into this career easily because they won't get right mentors easily. They'll go to Udemy and just want to do for $50. They see for few videos, but they don't understand anything. They forget and they go to Java. Java Hello World, they will start here and there. They start applying. Nothing happens because there are millions of Java developers. Okay. Anyway, let's come as a data and AI goes together. As I told you, data engineers have more demand because AI and ML is booming. Manasa, is there a day you didn't hear about machine learning and AI?
No, these days it is very important. I'm hearing everywhere.
Even if you close like this, everywhere people are going crazy.
Yes.
There is nothing like AI and ML, guys. It is not something like another skill just come and go. No, it is a new order. It means it's a new order. Like IT technology, is IT gone anywhere? No. 20, 25 years back, a boom has come. The technology has not gone anywhere. You go and see colleges, there are now nobody joining mechanical engineering, nobody joining electrical engineering. Everyone is AI, cybersecurity, CS. Yes, Manasa, is that correct?
Yes, Srini.
Earlier, only 30 seats, 50 seats for CS, mechanical engineering, all these things. Like the technology has not gone, like that ML and AI will not go anywhere. ML and AI is not another skill like a Java or VB. It is not a skill. It is a new order. It is a new order. So because MLA is taking off, data engineers have more demand. That is the reason data engineers demand has grown. Shanmuga, you understood why it is?
Srini.
Yes. So as a data engineer, your role is in fact do ETL grow. Your job is to do ingestion, data ingestion into bronze, silver, gold. Most of the time is this. Okay, you may be doing 20% around it, but 80% batch jobs, streaming jobs. Like, it's right. If you go to temple, you say, Hare Rama, Hare Krishna, Hare Rama. Like that you'll go, right? They will be doing the same thing. They will be doing same thing. Shanmuga, right?
Yeah. Yes.
You go to Tirupati, you say, hey, what do you say, Tirupati? Line when you're in line.
Govinda.
Yeah, same thing. You see, that's Srinivas Sakamure. Awesome. Awesome. Okay. So ETL right now you are doing batch, streaming, Harun also shown. Both of them, whatever discussed in the class, please be good at it. You don't have to do brand new things. First to finish this. But the next topic is on the ETL. Murali, there is one more way of doing ETL. It is called delta live tables. Till now, you read and write to delta tables. You read streaming and write to delta tables. Now there is another ETL technique. Only this is created by Databricks. This only works in Databricks. Whereas Spark, even if you don't use Databricks, Spark works on Hadoop, Spark works on even Snowflake, Spark works in Amazon, Spark works on Azure, even if they don't use Databricks. Because Spark is an open source, but interestingly created by Databricks. Databricks is the leader. They created. That's why there is a leader, Srinivas Sakamuri.
Yes.
Why this Databricks is leader is because they created all this technology and given to free to everyone. You know, you take it. Even Snowflake uses that Spark. Of course, they modified a little bit. They got Snowpark. The PySpark, all these things is created by Databricks and given to open source. Of course, now since it is open source, a lot of people are still developing. But now Databricks has taken this to next level into Databricks platform and made it more robust. And now they added some proprietary sauce. The proprietary way of doing ETL is called Delta Live Tables, DLT, Delta Live Tables. Delta Live Tables does not mean just tables. Of course, there will be different tables. The word don't get confused. DLT is a way of another ETL. Okay. Again, in summary, everyone, Shanmuga, Srinivas?
Yeah, delta live tables are another technique for ETL.
Another ETL technique. Till now, you do batch ETL using Spark.
Yes. Yeah.
PySpark. Streaming ETL through Spark. Now, DLT is another way of doing ETL using still Spark, but there is a different way of doing it, just a different way. So what is that? Harun is going to train us today. I'll give some basics to you. So if someone, Shanmuga, if you can share your screen as I talk, spend another 15 minutes and Harun will take over. Okay. Again, one-liner. DLT is another way. Instead of now another way, I will say a declarative way of doing ETL.
What is the abbreviation for DLT?
D for dog, L for love, T for Tom. Delta
Yeah. Sorry.
live tables.
Delta live tables.
We get into your Databricks system, the Microsoft. Okay. Everyone. So first again note, DLT is a declarative way of doing ETL. What is declarative? Anyone? Declaration.
Means they're declaring some variables or kind of way. They are declaring something before processing it.
Exactly. Declaring, like a very well said, Srinivas Sakamari. So exactly, if you see Manasa, this is very interesting field. It's like a gold mine. See, in ETL, what you are doing, from where I should read, number one. What I should do, extract means from where I should read. Transform means what I should do. Load means write, where I should write. Is there anything other than this high level? Manasa, tell me in ETL.
No,
Yield
nothing in.
extract. Where I am reading, from where I am reading, of course, what format, etc. What I am doing, what transformations I am doing, where I am writing. Where I am writing. Okay. So instead of you are reading using Spark, you are doing some transformations, you are loading it. That is general way of ETL. Anyone will do. Declarative is looks the same way, but in a little more easy way. Little more easy way. And I say little more easy way, you still tell from where you are reading. You still do some transformations. But only thing is when you're loading, you just tell to your code, create this table. That's it for me. See, when you read, you are getting a data frame. When you transform, you are getting a data frame, but in the program. Then you are saying is save as.
Yes,
In
yes.
DLT, Srinivas Chakumari, we will not use the things as save as.
Okay.
Instead just create, hey, I got it. Just create this table. That's it. So you declare it. You will not say spark.write, spark.do this, like that. Because anyway, the idea is I get this data frame. That's it. You just get it. Then say DLT table, DLT table. You declare it. That way it will go and create. Number one. That is just programming perspective. Number two, DLT allows you to set the rules on the quality of data. I expect this. I expect date in this format. I expect a not null value. And the question is,
like means they're doing the data quality check as a transformation. It is as a default. You're declaring something before you
declarative. Very good, you said. Instead of checking, oh, if this is, expect this.
Srini, you mean we can specify the constraints?
Correct.
Okay.
Expect this. Then use if you expect or fail, expect some. There are 3-4 commands. Expect, give warning. Yeah, I expect this. Even if I don't expect this, I'll write it. But at least put a note. I got a bad data. I expect this. If it doesn't meet, fail it. Fail the process. I expect it or mark it here. Okay, I expect this, but do allow it for now. Like that, you can declare, Shanmugam. You'll understand. And first, let me tell you. Then the third, because DLT is not one thing. First is declarative way. Second is you set the quality rules. You can set the qualities. Third is, see, when you are running your ETL pipelines, Shanmuga, don't you think you are running on a cluster? Correct? Running
So
on
we
a
are running
cluster,
on
right?
cluster. Yeah.
Of course, Databricks is also coming with a clusterless environment, which is called serverless. But even serverless or even clusterless, still under the hood, it runs the server. In DLT also, under the hood, it runs the server, but DLT optimizes very well running these servers. When it is running, it does very intelligent scaling. There is a concept called enhanced auto scaling. General infrastructure, general servers, general cluster has a auto scaling. Auto scaling means if the load is becoming big, you'll have more number of machines coming. Auto scale. If load is less, if you have 4 machines, it will go to 2 machines. But in DLT, there is a concept called enhanced auto scaling. It will do more efficiently. You'll know more about it. But have that. It means DLT manages infrastructure for you. That's all. 3 points. DLT is a declarative way of mentioning the tables, not only a declarative way of mentioning the table. You can declaratively update the tables. Update is very big, guys, in big data environment. I don't know if you guys have updated any tables. If not, Harun will show you in coming classes. Update, when I say update, is a big table, updating a big table. Like a, what do you call it? Upset? Srinivas Shakumari?
Yes, sir.
Can you tell to our team what is upset?
Means it's doing the update and doing the insert, both to be together as upset, like a merge.
Exactly. Shanmuga Manasa. You might have heard insert. Insert means insert. Insert this row. Update means you update
Updating
when
new values.
the key matches, right? When the key matches,
Yes.
you cannot just update, right? What do you update? Update these rows. It means update this table when the key is matching. Okay. So Srinivas Sakumar is saying upset. Upset is update or insert. It means if the key matches, update. If doesn't match, insert. That is called upset. If key matches, update. Otherwise, upset. So how you do upset operations?
Only in the database, we are using a merge command. Using merge, just would like to do the update or insert.
Correct. So instead of doing all those update statements in DLT, it just says apply changes. Apply changes. Or target key is this. What is that? Source key is this. These are the columns you update. Just declare it. You just tell it, update this with these conditions. It will do it for you. So like that, DLT is a declarative way of doing it, number one. Number two, it does the error checks, expect or that type of things. Third, it manages the infrastructure. It manages the pipelines. You can create it as a pipeline. Before I quickly show you some quick code, anything you, Harun, I'm missing before you take over? But first I will quickly show them. Those
No,
three
sure.
parts.
Yeah,
I want to
yes.
simplify it, put some
Good.
thoughts on their minds, in their minds. Excellent. So, Sharma, give me 1 second. Excellent. Okay. So this is how it is. You please see here. This one diagram, keep in the mind if it is DLT. So DLT, you know this is branch. Your aim is to load into the branch as is. Then do some transformations and write it as silver. Do some aggregations, write it to gold. Nice picture, right? Shanmuga, nice picture, right?
Yes. Yeah.
So don't worry about these colors. They look the same, but gold and bronze also look the same, you know. So it's okay. So look here. So DLT, Delta Live Tables, is a little more robust way of doing it. Still, it uses Spark and it uses a optimized Spark, which is called Photon. If you haven't heard about Photon, you'll be learning soon. Spark enhanced optimized version is Photon. Okay. Again, still it uses, so DLT means still it is a Spark only, but a declarative way, number one. Number two, it's see, you can continuous or schedule. You can schedule the DLT or you can run it continuously. It means both streaming and batch is there in the together. Srinivas Sakamure.
Yes, sir.
You can run it scheduled. You can run the same program in streaming. You don't have to write two different programs. Srinivasa Kumar.
Okay, it's a live and it's a streaming and it's a regular batch job.
Exactly. You can do both. Run it every hourly, run it every 15 minutes, you can say DLT, or run continuously, you'll say. If you
Okay.
say run continuously, the same program is running as a stream.
Then we don't need to worry about the other two things. If we know this one, we can continue as a batch job
Both.
as a streaming process. Okay.
Exactly. Only thing is still, if you are reading from a Kafka or reading from the disk, that you will tell.
Okay.
Even in Kafka, you just read every 30 minutes, right? It can read Kafka, even though it is streams. Only when you read it streams, right, Srinivasa Shakumari?
That's true. Yep.
Otherwise, it will wait for you 30 minutes. Then
Yeah.
whatever it comes, you take it, or every 10 minutes you take it. Even streaming is also a kind of a batch, micro batch, right? See, every 1 second you are reading. Even it's a 1 second batch, correct? Streaming means.
Yeah.
So they mixed both. That's why you see continuous batch or streaming. So it is a unified, number one, right? See, data transformation, when you are doing data quality checks, it does error handling and automatic recovery. If there is any errors, you need to restart. Shanmuga, Harun has taught you how to set this checkpoint location, right, in streaming?
Yes, he said it.
So in DLT, it defaults. If you don't specify a checkpoint location, it creates a checkpoint location for you. Okay. So it does the error handling. So the checkpoint is if it rerun, it knows where to pick up. Then the data pipeline observability. You can see the graph easily, and there is a more observability features. Next, automatic deployments and operations. You can automate deploying them through APIs. Orchestrate data pipelines. In the workflows, you can create task, run one DLT, next run another just ETL pipeline, another DLT. Like that, you can team them up. You can create a orchestrate workflows. When we discuss workflows, we'll help you on that. So in summary, Delta Live Tables helps you to maintain data quality. It still runs in Spark and Photon. You can maintain data quality at different stages. It's a declarative way, and it is a only specific to Databricks. Only you can do this when you run the Databricks. The whole goal of your role is to create bronze, silver, gold tables so that they will feed into AML for data sharing and SQL analytics. Hope this picture sounds good.
Yes.
Gives a good. A picture speaks better than. Okay. We have multiple sources of codes. I'll share it to you next session after Harun covers some good stuff. Harun always wonderful stuff. So that's why I love to collaborate with him. Okay, super guys. Shanmuga Srini, please see. I just want to share some small code snippet. Please see. It is still a notebook. It is still a notebook. You do some imports just like any other imports in PySpark. See, in PySpark, you import SQL functions, SQL types, SQL functions as F, something like that. But this is one thing that is specific to DLT. Just one thing, Manasa. Import DLT libraries. After that, you see, so declarative way means you declare an annotations. We say at dlt.table, dlt.table, and this is one unit. Please look at. Please look here. It means a DLT.table, some comment you can give. This table, I'll be any comments, source data. In this table, I'll be taking some source data and loading it. But how it is creating the table? Look here. In this function, this is the function you see here. This is a Python function. Manasa, simple function. Definition, DLT source table. What it is doing? It is just reading a table, spark.table. It is reading from some source table. This is the schema, Iowa delta. This is the table it is reading. So it is returning a data frame. That's it. You read a table, you just say the word return. It means you got a delta frame. Then it creates a table called DLT source table. This is the table it creates. Using this data frame and writes it. So nowhere you mentioned read, what do you call it? Read is okay. At least you won't say write. You just say return. So add DLT table means I'm creating a table. And what is the table name? Interestingly, this function name itself is table name. One option is you can mention your table name here. If you don't mention here, whatever your function name becomes the table name. Awesome. This is a simple table you have created. Sometimes if you are reading from Kafka, you'll read from Kafka here. If you're reading from batch, you'll read from here. This is an example where he is reading from a table. Okay, no issue. You know how to read a table. Read a table, return that. Return means that's it. And it writes to this table. This is the table name. So it's a simple 2 lines of code declaration. It creates a table. Number 1. Next you see number 2. It's creating another table, DLT table. That table comment is corrected data. You are doing some corrections. What is that corrections? Okay. Look here. You are expecting some rules. Here, my city should not be this. Next, it means you're expecting that's it. But you're not failing it. Look here, the second. I'm expecting this ID less than 5. I'm expecting if it doesn't meet my expectation, drop that row. I don't want that row. Okay. Different rules. I'm expecting a date. Date should not be null. If it is null, Srinivas Sakamori, fail the process. Fail the process. Earlier, you see, you dropped it. Earlier, you expected it, but you allowed it. You have a lot of flexibility. There are 3 to 4 kinds. So these are the expectations. So in this, I'm creating a DLT table. I'm doing these expectations. But from where? Yeah. See here. Return. There is a function is here. Def DLT. This is the name of the table. Just like this is the name of the table. If nowhere name of the table is mentioned, your function name itself becomes a table. It will be a little confusing initially, but you get used to. This is a definition. Your return, yeah, you can say spark.table, or you can read even from a tables using DLT.read. Few syntax you will get used to. But you see here, just to first try to understand. DLT.read, I'm reading it. Again, Harun made us very strong with transformation rules, with column, sale order. Instead of sale order, you are adding $200 extra. That's it. You got this written. This written will be Srinivas Yakamori. It will be, you just have to get written it. If written it means it writes. It writes where? This is the table name. Where did we mention the table name? We didn't mention any table name. That's in, when you don't mention the table name, the function name itself becomes a table name. So this is one set. This is one set. This is one table created. This is second table created. So this, assume this is the raw table. This is, assume this is the, what is called, bronze table. Sorry, silver table. Some transformation added. Now you are writing gold table. Look here. DLT table, aggregated data, definition. This is the table you are creating it. You are returning it. DLT.read. This time you are reading from this table. Look here. DLT corrected. DLT corrected. You are reading from here. From silver table you are reading it. You're doing some filtrations. You're doing some group by aggregations. That's it. You have a gold table. You have some silver table. You have some raw table. This can be even from the disk. This can be even from Kafka. So there is another concept here called autoloader. We'll talk tomorrow, which reads the folders continuously. But that is the basic start, guys, like A, I, E, U, like alphabets. Srini, I'm just giving a sense of it. Then as you do, you get the idea. So DLT is a declarative way. Just you'll be mentioning the tables. You'll be creating the tables. You will not say, write this table, that table, this table, something like this. Whatever this particular data frame I have, write it. You can expect the rules. Whatever you're returning, you'll write it. Whatever you're returning aggregations, you'll be writing. You want to put additional any expect all or drop. Something, a lot of rules are there. We'll go through details. But any questions, at least to get the idea about this. Srini, Sakumar, before Harun will take it forward.
Yeah, just I'm clear on the list.
Just got the little bit of understanding, right?
Yes.
Shanmuga, you got the hang of it at least?
Yes, Srini.
Manasa, I know it will be a little confusing, but at least you got the little bit idea?
Yes. Yes, Srini.
Murali?
Yes, Rini. Yeah. Yeah, I got the little bit idea, but yeah, once
That's
or
fair enough. That's fair enough.
articles.
Because
Srini, just a
anything,
small doubt, Srini. If we don't write any R class, what is the use of mentioning the expect in the
what is that? What did you say, Vikas?
if we don't write any R class, like what happens if it doesn't?
Oh,
If
that's
the
a
data
good
is not
question.
how
Yeah,
we expect.
it
the
writes
use of-
somewhere it marks. Hey,
Oh.
this row failed this expectation. It writes a additional in the column. It puts a marks so that you can do some reporting on that, Vikas.
Okay.
But the great question. That was a great question. So I have multiple examples. Even there is one example which has even complete excellent examples are there. I don't know if you have access to Medium. Even he gave very good examples. Probably we can do it as a what do you call it, as an assignment. You may not be able to do in the class. So there are a lot of examples. So here data quality shows the graphs also, how many dropped, etc. all these things you can do. It shows you when you run it, a pipeline. It looks like this. You can get the weather data and load it into some silver tables, load it into gold tables. You can see each one, how many completed, all those things. This is how the Delta Live table. Look here, workflows, Delta Live tables. Let's start. I think I will stop here. Harun, I hope that is a fairly good intro. Then we can take it forward. You take it to next level. Then we both give them good assignments so that they practice this whole week. So this whole week is Delta Live tables week, guys. Focus on this. If you know in the market, if you say I know Delta Live tables, they really appreciate. A lot of people don't know about this. It looks a little bit unconventional, but it's getting very popular, guys. Okay, Harun, does it help?
Yep. Thanks, Srini. Yes, definitely. Yeah, as
Super.
you said, right? So whatever we have done till now was the foundation. So you should get comfortable with that bit because going forward, things will get a little bit advanced. So we have to have a strong knowledge of all of the things. So basic what we have done is, as we said, 60 to 70% of day-to-day what you do, like, batch, read files, do transformations, write, right? So those data pipelines that you do. So that is the basic foundation, 60 to 70% of the time. The rest 30% is basically the advanced features, what you have to know what happens, right? So advanced features, what's coming in Databricks, like DLT, and then advanced features like so what we do, workflows, DLT, then what happens, what's Apache Spark, how does distributed computing happen, what is the DAG, right? How does it process the data frames? How does the shuffling happen? What are the merge strategies? So all of the internals, Spark internals, Delta Live, so see the Delta format, Delta files. So what is the format? What happens underneath? So we have gone through that Delta, but I'm talking all of these are knowledge that is very important to know. So DLT might be there 10 to 20% in your workspace. Yeah, but 60 to 70% is the basic what we have done till now. So going forward, things will get a little bit more advanced. But if you're comfortable with what we have done earlier, then it should be easy to continue from here. Right?
Yes, sir. Yeah.
Yeah. So are you guys good with what we have discussed till now? Basic transformations, medallion architecture, data frames, transformations, batch reading different formats of files, streaming, right?
Yes, sir. Yeah.
Okay. So a couple of questions. How many of you guys have created the paid version of the Azure Databricks?
Yeah, I did that one, Arun, and I practiced that live streaming as well in that.
Oh, awesome. Great. Guys, anybody else?
Harun, actually, I am using the free subscription only, but they
Okay.
also given some credit. So I also practice it streaming. It's working.
Oh, okay, great. Great.
Same for me as well, Harun. I have that student thing that has 200 credits for both the year. So
Oh, awesome. Awesome. Great. Okay. Great. And second question I had. So any of you registered for the event that happened on Thursday? Attended?
No, Arun, I didn't.
Anybody from this team? No one? Okay. That's fine. So because see, basically what they had was we discussed about the DLT only. Okay. So what we will do, I will just go through that lab, what we have done in that session. So they have given an environment where you can go in and run that lab experiment or the assignment, the demo what they have done, and it is only valid for 60 hours or something. So By the time we finish the session today, I will lose access to that environment. But anyways, I have my own paid environment also. I'm trying to set up that. I'm getting some issues. I'll figure that out today. So we should be good by tomorrow on that. But I have the lab environment still accessible today. So I'm going to show you what we have done in that assignment or in that event on Thursday. Same thing for DLT. Again, so what Srini was showing DLT, right? So you mentioned is that Python, right? So what is the other way to do any of the data frame other than Python?
Using SQL or GUI.
Sorry,
Using SQL.
SQL, yes. Okay. Okay. So the experiment, the assignment, what we have is written in SQL. I mean, basically you can do Python also at the rate DLT. So declarative comes with the DLT. Okay. SQL comes as CTA statements. You just create and then you use some keywords like live and stream to access those tables in the SQL, and then you go ahead and create them. So let me start and see what we have done there, and I will start with the that experiment. Now experiment, basically that demo example that we have done. Okay. I will go through that today, and then we will continue with more examples. Okay. So this is the lab guide that was done by Databricks on 5th, right? So what we had done is there's given an environment where each of the user who have registered will get a user ID and then credentials to the environment to log in. And then we have a GitHub repo. Okay. So in that GitHub repo, you get all the code base, basically the files, the notebooks that you use, the volumes and the files and all of that. And how you do check out that GitHub repo into your folder. So let me go here and see. Do I have that? Okay, so if you see here, this is the Databricks repo. It's open, so you can use any of this code and you can clone any of this. Pipelines workshop is what we have done in the session last week or on the 5th. Now there are other examples also. Slowly, you guys, when you get comfortable, you can start exploring and working on this. There is a New York taxi fares. So there's a pipelines workshop that we are going to do now. And this also we will try to do once I have my environment, but it will be more like collaboration. You guys should start working on this and start doing demos or figure out things and start doing demos. Okay? As assignment, as Srini was saying, there are some resources Srini will share and I will also share. You can go here and check this as well. Okay. So if you see here, it will give you the code. This is the notebook for New York taxi fares that are talked about. You create the taxi records. See the data set they mentioned. This is the data set that you can use. We know we have Kaggle, right? So we get this data set and then upload to your volume somewhere. Create a volume. It's like storage, and then upload this file there and start creating the tables. Like this pipeline, and then create a pipeline for this and run. Simple. But there is a one-time kind of setup that you need. Your workspace has to be Unity catalog enabled. We'll talk about how Unity catalog. Then some runtime issues basically with the compute. So you can use serverless, how you can set up that serverless. We'll also talk about it. Okay. But this is the basically the repo that you can use to practice. You will have all the um, source files where you can get, and also the code base. It'll give you a good hang of take the notebook and create the data pipeline and run and see, right? So there are other things like you have the Gen AI. When you get more advanced after the data engineering, you go into Gen AI. Cookie demo that was done in the Data AI Summit a couple of months ago, I think. In the Data and AI Summit, they gave a demo on this. So it's the same, it's that repo that they have used. There is a NASA-based one more satellite, not satellite, data. So NASA data that is on Kafka. You're talking about streaming, right? So there is some Kafka open sourced Kafka topic that NASA is providing, where everybody can log into that Kafka topic and read data, streaming data from that. It's open source. So that also you can explore going forward. So there are quite a few things which are exciting to try out, and believe me, it gives you extreme satisfaction and pleasure when you figure out things and start seeing the output, right? So think about it. You're just reading what NASA is publishing directly in your own environment. All those satellite data, about something like some events happening in the galaxies. They keep publishing that events. So something like, I think every 10 minutes, 20 minutes, you get some event. So you start ingesting, reading data from Kafka, build a DLT pipeline or something, or a streaming pipeline, and then start reading from it. So that is one very good assignment that we can talk about. Now, coming back here, so this is the GitHub folder. And as I said, for this example, we are doing this pipelines workshop. Okay. So this is what we have cloned. We will be cloning this. So there is a so the instructions how to clone it. Okay. And then you go and create this clone, check out, and then you get this repo in your work environment. First thing. Second, so once you have that, there is a serverless compute that is available to select to run. Pipeline name, you give your own pipeline, create the Delta pipeline and then run the pipeline to see the details. That's the first assignment, what it is doing and all of that. Okay. So Python for some reason is not enabled on this compute. So we cannot create a compute because it's a lab experiment. So only the SQL. So for now we'll do with SQL, but going forward, the other examples we can get started and run with DLT as well, the declarative pipeline examples. Okay. All right. So any questions on this?
What's the meaning of clone?
Okay, very good question. So this is, I think, basically the GitHub commands, the version control, and I'm sure some of you guys who have work experience have already used. So how how it works, the version control is see, you have a repository of all the code. Everybody is working in your team, right? So everybody is creating notebooks. Now it is in your workspace or in your thing. Now how do you, when you put it production, so any code you put in production has to be secure and maintained by somebody that nobody else can go and touch, right? Make any changes to that. Correct?
Yes.
So you have something called a repository. That repository, repository is the code that is actually running in production. You take a copy of the code that is running in production and put it in a version control, which is like GitHub. There are other things like Git bucket, something. So the idea is you have a master code base, which is running in production. That is the final master. You know, not allowed to make changes directly to it. Only you can create a copy of that entire code base on your local, create a branch from it. There you make your changes. And then you push it back to the repository. So between you push, after you push, there is a code review that happens. Okay. And they see, okay, this code is compatible with the master. Have you deleted anything or have you overwritten anything? Is there a conflict? Is the code working fine? Do you have everything tested? So when you feel like, okay, everything is tested, I have added 2 new notebooks for this pipeline or added some code or some validations to this pipeline, everything is running fine, then the DevOps team or whoever is in charge, they will go and merge your changes to the master. Now the new master will have everything, old one, and your changes as well, whatever you have added. The next time you again clone that master so that now you have a fresh copy of the production. So that's how this whole circle goes. This is called the CI/CD, continuous integration, continuous development. So you take a branch of the code, make your changes, review it, push it back, and then merge to the master. So this is the whole CI/CD DevOps. So you should, just talk about Git, how it works, how you in the work environment, how you use Git repositories, and how you clone the data, how you create branch, and all of that.
I don't know. One question about CI/CD
Yeah.
means continuous integration means normally every time we are doing the integration and migration to prod, all these kind of things, right?
Mhm.
But exactly the specific meaning content in that continuous integration and continuous deployment.
Yeah. So continuous in the sense, right? It again comes from the agile world. So you're taking a small piece, you're not doing a waterfall of complete overwriting or complete deployment of the whole stuff. It's you're taking bits and pieces. So it is, you are continuously, people are creating the copies and creating their own branches of the code. So not one person is just doing and then there is only one thing that is going to production, right? So
Okay.
every week, every 2 weeks, there are 20, 30, 50, 100 changes that are going in. And
Mhm.
everybody have their own pipeline,
Okay.
right? So everyone has their own branch. I am
Yes.
doing some changes, Manasa is doing some changes, you are doing some changes. So all 3 of us have taken a uh, production code base, copy, cloned, right?
Mhm.
Now I have added some code, Manasa has added some code, and you have modified some code. Now,
Yeah.
how do I get all of this into a perfect state so that my additions are there and your modifications are there? So there is always a conflict because the same copy is now in 3 different states. In
Mhm.
my copy, I have one. So let's say I copied X from production and then I added Y. So my copy will have X plus Y. Manasa has added Z. Her copy will have X plus Z, but she will not have Y, what I have added. I will not have Z, what she has added. Now you have taken that copy and modified X.
That's true.
So now if you push, merge it, the X modified X is like, say, X1. Now in
Yeah.
production, your code went into production, it became X1.
Mhm.
Now I'm going in, I am going to put x plus y. So if I override that, now your x1 is gone. Again, my x will come. So it has come back to the old state.
Okay.
So
Yes.
I should merge, make sure that your x1 is there,
Mhm.
then my y is there. So it should be x1 plus y, not x plus y.
Okay.
Same thing Manasa's code should go
Mhm.
and say it's x plus z. All of these conflicts are managed.
Mhm.
All of this version control is managed in the Git process. You have branch, you, you check the status, what are the files that are changed, you push, and then you manage the conflicts. It will show, the Git will show conflicts of existing master and your branch. What are the conflicts? What are the changes basically? If there is a new code, that's fine. As long as the code is working, it's not failing, you go and merge. But if the same file that you have modified, there is a conflict that somebody else has modified something and you have modified something, then there is a conflict. So you have to resolve the conflict, make sure the other people's code is not overwritten, and then you uh, merge it into the master. So all this process, it's called continuous. So again, it's not just how do you merge it. It's all pipeline triggered, right? You don't manually go and do everything.
Yeah.
It's all pipeline, DevOps pipeline is built. It's a click. You just click, it will do all of this conflict resolution check, and then give you whether you can merge or you can move to the from dev to test, test to pre-prod, and pre-prod to prod. So that pipeline is built. So this is not data pipeline. This is DevOps pipeline where whatever code you have added, when you click, it goes and deploys into the test environment, does all of this conflict management, and gives you a report whether you can deploy or not, or are there any issues with that. You have to resolve those issues. And then you click, everything is approved, then it will go to production. It will automatically merge, compile the complete code. I mean, if it is executable like jar files or something, uh, so it will execute the whole code baseline and see the build is successful or you're getting any errors when you're building that. So all of this process is called CI/CD. It was there already. It was more like version control. Now it is DevOps CI/CD where you manage the deployments, automatic deployments. Whenever you have a change, it will automatically deploy and validate and compile and see what are the issues with that. Okay, so just to get know that. So basically, clone means you are getting a copy of that whatever repository is there onto your local branch. Okay.
Got it. Thank you.
Yeah, sure. So if we come here, so duplicate this. So this is the lab environment I was talking about. So if you see catalog here in the demo, see all of these users were part of the demo that day. Okay. And my user ID is 1445176. So this is my user ID. This is what I use to log in. Okay. And these are the tables that were created as part of the assignment. I will walk you through. So just to give you a hang of things, what are all there in the DLT. Okay. So if I go here in the workspace, you see Git folder. You can create a Git folder and then give the repository. That's what we get. Sorry, somebody is asking something. Okay, so
Arun, this environment provided by the demo team, or how you got this one? I mean, this is your own environment.
no, this is we registered for the event, right? Thursday. Srini
Oh,
pinged
okay.
in that group that there is an event done by Databricks. So there was a 1.5 hour session, right, on generative. Remember, I also pinged in the
Yes,
group.
yeah,
Joined,
yeah.
So when you register for that, they will give you all of these credentials to run that assignment or to the demo, and it will have a 2 days or 3 days validity, 60 hours validity after that event. So today this
Oh,
environment will go away. I will not have.
oh, okay, okay. Yeah, got it. Yeah.
Okay. So this is the Git folder name, sparse checkout mode. Okay. Cone patterns is what you have to give the folder name here, pipelines workshop or NY taxi fares or whatever you want to pull that onto your local your environment, your workspace basically. Okay. Yeah. So here I can go and say invite taxi fares or something like this one. But anyways, they have mentioned in the lab that what you need to use, but in general, this is how you go and clone from any of this. I don't know whether this will allow, but no, already exists TMM. Okay, git folder name. It's okay. So there are some restrictions on this, but this is how you go and create the clone of this. So then you get this in the workspace. You get this repos here, TMM. Okay. So in this, you will have that pipelines workshop. What is here? The pipelines workshop. So all of this will be cloned onto your environment. Okay. So all you get this. So that is the clone. So once you clone this, now let's go to this notebook. Okay, so this is what is your building data delta live tables pipeline, delta live tables pipeline using SQL here. So this is a SQL notebook that they have provided. Now, what does it have? It have raw transactions, ref accounting, historical loans. So in the bronze layer, so basically you create the catalog here. In the catalog, as I said, it is automatically created for all the users. So this demo is the, sorry, not catalog, schema. So demo is the catalog. Okay. Schema, I will have one for me, 1445176. As I said, that is my schema in this. So this is the schema. Now in this is the first table, raw underscore tx. Okay. And that where is the data coming from? Loan IO raw transactions. Okay. So if we go here, what is the command to see the files?
dbutils.fs.ls.
Okay, display dbutils.fs.ls. Typing, not typing. Oh my God, what happened? Okay. Display dbutils.fs.ls. Not this one, right? What is the path? Path is okay. So this is the path transactions. To run this, you have a file called raw transactions. In that you have these in that folder. These are all the files, the part files, split into these files. All 600 rows are there in this. 600 files are there. Okay. So similarly, go back here. Just pull this here. Then accounting, reference accounting treatment. So this is new raw loan data incrementally ingested from cloud object storage. So we'll come here. So we'll just go back. And then this is accounting treatment, lookup mapping for accounting codes. So this is like your reference data. Okay. You're just checking the accounting data, the reference data for accounting codes, whatever the other information that you need based on the accounting code, details of that account. This is a more or less like static table. It's not streaming, but you can still use it as a streaming table. Then you have historical loans. So this is refreshed at a weekly basis. So here you are triggering this only once in 6 hours. So you can give a trigger interval when you want to trigger this once you start your pipeline. The data is here again, historical loans, right? So these are bronze tables, 3 bronze tables. And then you have your silver. So what you are doing in the silver, you're reading accounting treatment from raw Texas, raw TX transactions. So this is our source table, right? And then this is ref accounting treatment. This is our lookup table, joining these two. This is one table that you are creating new transactions. Then there is a cleaned new transactions. Again, where you see, remember just now Srini was talking about constraints. What constraints you are adding on each of these tables. And then you get a clean new transactions table from this. Then you are adding quarantine bad transactions. So whatever is the bad transactions, again, from the table, you are taking the bad transactions and writing to a different table, the data. So finally, you are creating gold table with accounting treatment, historical loans on this. Enrich all historical transactions. Sorry, that is not gold. So this is the gold. So in gold, you are creating 3 different views. First is total loan balances. Now you see here, as we said, we are doing aggregations. Okay. From this, historical cleaned. Cleaned is our silver table, right? Now, new loan balances by cost center. For each cost center, what is the loan balance? Then loan balances by country. For each country, what is the loan balance? Okay. Now, so this is the notebook. As we said, we are creating the live tables, delta live tables on all of these files and doing the transformations here. Now, what we are doing, we'll go deeper into this. So, but at least at high level, do you understand what this notebook does?
Yes, Haram.
Guys, come on, speak up. I know this
Yeah,
is
so this is only for the SQL only it works, sir. Right?
no. See, there are different ways of doing it, right? You can use Python, you can also use SQL. So this environment, what they have created, they have not given access to the Python libraries in the compute. So you have to do some setup for the Python libraries. That this is because a lab environment, right? So we don't have access to create new compute and all of that. We will do that also later. But for this example, it is SQL.
Okay.
Okay. But it does the same thing. You just rewrite, as we said, right? Data frames, it's all end of the day data frames, where you are reading from, what you are doing. It's just a syntax. Okay.
Yes, yeah.
Now, if you look at this, what is happening with this notebook? Can you guys see?
Yes.
Okay. So this is the autoloader, incrementally load new data. So these are the files that are coming in, raw tables and raw historical loans. And then this is the reference data that we set. So all three, the autoloader is reading. New transactions, we have joined with raw and this raw table with this reference data. These two tables are joined. This is a new transaction table. From this, we are doing transformations. Cleaned table, quarantine table. From this, you are taking, you are splitting based on constraints. Whatever is done, you put here. Whatever is failed, you read again and you put into different thing. Historical transactions, we are going back and reading with historical transactions and the accounting. So this is the lineage. Beautiful. See, you will know how this entire thing is being built. Whatever you want to see in troubleshooting in the traditional world, say some new balance is wrong. Where do I check? How do I know? So it will give you where the data is coming from. This table being built from these tables. So you can traverse back and see where the issue is. If the issue is here, does it fail the transaction? So it should be in quarantine. Or if it is issue here, it doesn't have the data, reference data in this. Why it is not here? Maybe it is not there in the master table, that information for that account, right? So that is the lineage. This is called the lineage. So it will give you an automatic lineage based on your notebook. This graph is automatically generated. You don't do anything. Based on your notebook, it will read everything what is happening. It will build this lineage and give it to you. This is how your notebook looks like. Your pipeline looks like. Okay. These are silver. And then here you're doing the aggregations. 1, 2, 3 aggregations. These aggregations are based on this data and this data. So these two are based on just this table, right? But this is based on both this and this join table. Okay. Got this?
So what is the main advantage of this one, Arun? Because the same thing we can do for the live streaming and batch process as well, right?
Yes. See, what we are doing does not change. How we are doing is changes. End of the day, we don't do different things, right? We do the same thing differently.
No, that's what, yeah. What is the advantage of this one?
Advantage is, see, now if you do batch, you don't get this lineage. This is the delta line. Again, it uses autoloader. It will automatically read files as and when it is coming in. You don't need to check for the stream and all of that. It will automatically read the data from the stream and it will give you exactly read once, right? And then you have this live transactions. So once this one notebook you write and publish, everything is taken care of. You're creating tables, you're updating tables. You can write your constraints, your data quality here. You can map the data quality. You can check the data. So this is all continuously running pipeline.
Okay.
Same thing you can do in batch also. I know you can create these tables in raw. You can create in these tables in silver, these tables in gold. You write the notebook. You can schedule with a workflow. Yes, everything will be same, but you don't get that extra benefits of constraints, and the declarative
Mm.
way of doing things, and then the serverless compute that it can automatically process, and autoloader, which can, you don't need to have ingestion. It will just give the location of the file. It will automatically read. You don't have to read the data, parse the data, and all of that.
Arun, one question here. Normally, you're saying we are passing the file, it reads, and if you give the destination, it automatically loads that file. Suppose if any file format changes, means earlier CD was showing the code, okay, but there was no debugging. Normally, just he's giving the data frame name, okay, and he's giving the table. It automatically creates a table, and it load, and it's doing the next steps. Okay. Here, suppose you are doing the incremental data load, okay. If any file format change or anything, but in this concept, we need to do all the same kind of debugging things, right?
Yeah,
won't
it
take
will,
long
it
itself.
will, it will tell you why it failed, where it failed, what issues that it had. So all of that audit logging is there. You can track that.
Okay.
Okay. So when you write here also, you can still give your in the DLT, right? So this will be creating based on the file format, what you are reading. These are, one second. So this is the cloud files, right? And it is a JSON format. You are giving infer column types true here. See, you're still passing the, as we are reading that CSV files that we are saying, right? Infer schema true. The same thing you are passing here. So it will automatically parse based on the columns that are coming in this. Okay. And then it will, it has schema evaluation, right? If it has new columns that are coming in, so it will add that columns in there when it is reading for schema evaluation, if it's true. Otherwise, if the data does not fit in there, it will throw an error. So it will log that error, why it is not there. You will get in the pipeline issues, right? Expectations. You can go through that and check what is the issue, why the pipeline has stopped or paused. All that information is there. Okay. All right. So let's get started on this again. So we'll go through this one more time. Create streaming table. See here, this is not just the normal table. It's no, you're not creating a SQL or Delta table here. You're creating a streaming table, which it will identify as a live table, that it is a streaming table, can be used in the DLT. So this is the syntax. When you do Python, you declare, right, @DLT. So then it creates a streaming table. The same thing here. You put the keyword called streaming. So create streaming table. This is the table name. Comment. Yes, just like in DLT, you write this comment. New raw loan data incrementally ingested from cloud object storage landing zone. So this is raw data. It is being ingested incrementally from cloud object storage. So what means is, as select star from, see, you have given cloud files. So this is, please note this, cloud files means it is an autoloader. Okay. There is a file location which autoloader should continuously monitor for new files and then read the files from this path. So this is the path. You create a volume, demo, loan, raw, transactions. That's what we have seen here, right? So this is the path. Volumes, demo, loan, IO, raw transactions, which is already there. So you can create your own volumes in the your schema, catalog schema. You can create a volume, or it can be an external path, like on ADLS, S3, whatever external location. You can create a volume and then give that volume here to read the files. But it needs to be a cloud files so that it knows that it is a streaming table. Continuously, it will monitor and ingest new data. Format is JSON of the files. See, this is to read from source. Like we say rate for streaming rate or Kafka or whatever you give the source, same thing you do cloud files. You give the path and say at that path what is the format and what are the options. Cloud files dot you infer the column types. So this is the first table, raw transactions. The second table is accounting treatment. Okay, reference data, create materialized view, lookup mapping for accounting codes, as select star from delta. So this is already a table. It's not a file that you're reading, or delta file. You say the Parquet file delta dot. You are reading, creating a view from this file. Ref accounting delta dot. You are going to this path, reading this file and creating a materialized view based on this data. So this is not continuously changing. So we don't use cloud files or continuously ingestion. This is more or less like a static data files. So we are creating a view here, materialized view. All good? Any questions? Okay. There is another streaming table, historical loans. We give in the properties, we give the trigger interval that it should trigger only when even if the pipeline is running, it should only refresh once 6 hours. Okay, not continuous. Raw historical transactions from cloud files. Again, this is the location. The path, the format is CSV. See here, it was JSON. So this is CSV. Now again, you do infer column types true. So this is your raw. Now coming to silver, again see, streaming view, you just give live here. What we are doing, live stream of new transactions, select transactions dot star accounting treatment from live dot raw transactions, stream of live dot transactions. This is how you have to give for stream tables. Streaming tables, you should always qualify with live. Okay, here also you see live dot accounting treatment. We are saying it's a streaming table. This also we are saying streaming table, live dot raw transactions. We are joining these two on account treatment ID equal to ref dot ID. So you are selecting all columns from this raw transactions table and accounting treatment. You are selecting from this table. Then cleaned new transaction. So this is actually where you are doing the transformation. So again, streaming table, constraints you are writing, payment should be this year, which means this table should have only the payment date greater than. So I think this was done in 21. So current year should be this year means 21, or it could be 24, whatever, based on the data, whichever date, but it's a condition that you are checking. Balance should be positive is another condition, greater than 0. On violation, drop row, these two. On violation, fail update. So cost center must be specified. If the cost center is not there, you just fail the entire update. You will not move forward on this if there are any null in the cost center data. Select star from stream, live new transactions. See again, you say live dot new transactions. This is what you have built here, new transactions, live table view. That was built on live raw transactions. This is new transaction. You're using this to get to the cleaned new transactions. And as I said, so whatever is failed, the bad data, we want to quarantine. If the payment is not this year, take all those records. If the balance is less than 0 or not this, take all of this data and then from new transactions and create a quarantine bad transactions table. Okay, all good data will go into this table, bad data we are reading and then writing here. And then there is a historical transactions. We are reading from live.raw historical loans. So if you look at this, all of this, it looks confusing. But the moment you look at this graph, everything becomes clear. Oh, I have this table, this is being built, joining these two, this is being built from this and this, right? Everything becomes clear once you look at the picture. Now, these are all my silver tables. This is the good data, clean data. This is bad data. And this is the historical transactions I'm building based on historical loans. Now, if you go to the gold layer where I'm building the aggregates, total loan balance is just sum of revolving balance address state as location code from historical transactions. Okay. Historical and new loan data for unified roll-up of loan balances. Group by address state, union, balance, group by country code. So this is historical, this is clean new. You're taking aggregation of both and combining it into one materialized view. This is again same from clean new transactions, balances by cost center. This is by country code. Basically these two. You got it? Any questions? See, it's all just writing some sequels and referring to the tables. Silver, bronze, whatever we talk about it here.
So what is that interface column is equal to true? On top, if you scroll up.
Yeah. Where is that?
It's the beginning, I think.
This one?
Yes, yeah.
Yeah, this is what we discussed, right? Column types, infer column types, data type, whether it is an integer, string, date column, whatever it is, we are not giving that schema. So it should automatically read from the file and infer the schema.
Island. Okay.
That's the same thing. Here also it's the same thing.
Okay, infer column type.
Okay, just give me 1 second. I'll be back. Just give me 1 minute. Just Okay, I'm back, guys. Now, are you guys still here?
Yes, Arun.
Yes,
Oh.
sir.
Okay, so that is the notebook. Okay, at least even if this lab is not there, I will give you this GitHub. You can just go there, open it. Even if you don't clone, you can just go here and click and see that. You can still see the source code. Okay. And slowly you can build your environment. Once you can figure out the environment, then you can start doing those examples. All right. So that is the notebook, right? Now, once you have the notebook, the next thing you have to do is, see, this is the raw transactions that we have run it. So once you have the notebook, you have to go and create the Delta pipeline, correct? So you go here, Delta live tables. Okay. And then jobs or whatever. So you go Delta live and then create pipeline. Once you create pipeline, you give some, this my pipeline and say serverless is your, whether you want to use a serverless or you want to use compute. So here serverless is enabled for this environment. So I'm getting this serverless option here when I create pipeline. Now pipeline mode is triggered continuous. So for development, I'm using triggered. It's not continuous. Whenever I trigger, it will run. Path. So what is your source code notebook? Okay. So you go here, select whatever notebook you have created. So use this notebook. Catalog. This is your catalog. Schema target, as I said. So I'm using my schema where I have access. So use the schema. Okay. And then I think this all is just, you can just leave it. And then you do create. It will not create because it is already there that we have the tables and all that in the schema is already created. So this is the process. So once you do create, it will get you a pipeline thing like this, and then you can go and start your pipeline. So once you start your pipeline, that is when it will evaluate your notebook, generate the lineage and everything here. So we can go, I'll just go here. So go this. So this is the pipeline. Okay. And then you can say start. So when you start the pipeline, it will read your notebook. See, you can see your source code here, what notebook you are using, what is the user, what is the pipeline, everything. So it creating update, waiting for resources that we are using the serverless for this.
So below are the logs, right, Harun? Like info, warning,
Yeah.
error.
So whatever is the for the pipeline,
Okay.
go and check your logs. So if you go, yeah, so it's coming up. Okay. See now, this is the old one. Yeah, I don't need. Okay. So this is the lineage that it has built. So raw transaction, accounting, raw historical loans.
So Arun, this is built as per the notebook.
Yes.
Okay.
It will read what table is referenced from what table, all metadata, because it will not execute cell by cell. It will read the entire notebook and then create this graph, and then it will see which table is calculated from which tables, which has to go first, and how you have to structure all of this. And see here, I can use this. So these are the base raw tables: streaming table, materialized view, new transactions. These two are the tables that are built from here. This is the table built from these two. And these are the aggregations, materialized views that we are building here. Okay. Now, so this is completed. See, there is no more data to be written. This has completed. Now you can again go and start. It will restart again because we said our pipeline is triggered because in development. So there are two ways. Production, it will be continuous. It will continuously keep monitoring. Or if you want the same thing, you can go and schedule this whole thing using workflows. I want to run this pipeline at certain times of the day. So different ways of keeping it continuous. I know there are a lot of things doing, a lot of ways of doing the same thing. End of the day, we are continuously reading the incoming data, ingesting, transforming, and aggregating the data, right? So if you go here in the SQL, don't have SQL. Yeah. So you have this data here. Let's say select star from quarantine, new loan balance by cost center. Okay, 56 rows. Let's say we want to delete this. And data. Oh, I think this is a view, right? So it's just calculated based on that. Now what happens? Where is this? If accounting. This is clean new transactions. Okay, so now there is no data in this. We can go and start again and see if it'll run an update. So you have to restart once the data is already in there. Basically, it will ingest only the new data. So you have to restart the pipeline or reprocess the data. So that is all you have to do in the pipelines. But once you start and run it, it will continuously read and ingest the new data. What's happening with this? Okay, it's starting. But yeah, that is the overall the notebook that we want to talk about. So any questions you have? So there are other examples I'm also working on in this environment that we want to do, right? So Unity catalog the volume. I will just set up these for tomorrow fully. And then we will go through the DLT thing as well. I'm just trying to figure out, I'm getting some
What is Unity catalog?
okay. So Unity catalog.
Like, do we have to pay more to have that set up to our workspace?
No, I think it comes default, all the new workspaces that you are creating. It automatically comes with the
Unity
user
catalog.
agent.
Okay. So is that kind of a technique to manage?
It's kind of data. It's a catalog that is managed. So normally, if you don't have that Unity catalog in the workspace, you see only the Hive Metastore and samples. You cannot create this. If you can create a catalog, this Unity catalog, this is in the UC workspace. This has its own Metastore. So this is the Unity catalog enabled. So only if you have Unity catalog, this governance is done basically.
Oh, the
Delta tables, delta sharing,
schemas. Okay.
Yeah. So you can. It's just like same thing. Here you have Hive Metastore. This is a database. So here you call it catalog, and then this is your schema, and then you can have tables in this. I can create tables here.
Right.
Okay.
Thanks.
So we'll talk about it. This is Unity catalog is very important because going forward there are initially used to have Hive Metastore. After Databricks created more and more features that are Unity catalog, they created Unity catalog for governance, a new model. So based on that, now there are some features which are not available in the existing Hive Metastore that is being used. So we have to migrate from Hive Metastore to Unity catalog. So those projects are coming up currently in the market. A lot of customers who are currently using Hive Metastore, they have to migrate to Unity catalog workspace, UC enabled workspace. So we have to migrate the objects from this Metastore to this UC enabled catalog space. So those are some of the, generally you will have upgrade projects like that, right? So same thing like that, you have UC migration projects for Databricks that are coming up. So what I was showing you, so these are two different workspaces, right? UC workspace, Databricks demo workspace. If you go here, and if I go to this workspace and go to catalog, see it only shows Hive Metastore samples. I cannot create a catalog in this because this workspace is not UC enabled. For some reason, I don't know how it was created, but this does not have the Unity catalog enabled in this. But this is a new workspace I have created. which has the Unity catalog enabled. I created a pipeline. I'm almost there, I think, but getting some errors. We'll fix it hopefully by tomorrow. Just like resources, not having enough resources to execute this. I'll have to check what compute we have to use, how I can enable serverless for this, and then use that. So once we are good with that, then we can run our own examples. But I wanted to show you this today because this environment will go away today. Okay.
One thing, Arun,
Yeah.
so what is the advantage of the serverless? The process will be fast, or
Serverless is like you don't have to worry about the infrastructure, which machine it is using, how many machines it is using, what is the size of the machine, what is the RAM, what is the all of that. You don't have to worry about. See, first initial days, there is a lot of progression, right? So initial days about 2015, 16, when we started with Spark clusters on-prem or whatever, the cluster, everything has, you have to build it. You have to have machines, you have to build a cluster, you have to make one machine master, and then you have to create 3, 4 machines as workers, configuration, and then put everything together and configure, saying that, hey, master, these are your workers. In the JSON format, you say this is the IP address and of this machine, this is the worker. Like that, you have to create the entire cluster. When you do that, there was a whole lot of analysis and study that was done, that had to be done to see what are my workloads, how much is the data volume that I'm processing, how much time it will take. Most common was out of memory errors. How do I handle that? Do I need to have more workers with less RAM or space, or do I have to have less workers with huge RAM? Based on how I'm joining my tables. There's a lot of thought process analysis that were done at that time just to make the infrastructure to run the jobs. Step 1. Step 2 was, fine tuning that slowly. It then came. So once you run the jobs, you will understand, okay, these are my loads. So whenever my load changes, if I want to do a new load or reload everything, again, I have to use the different cluster, and kind of all that complexity was there. Fast forward some changes, the elasticity came in. We went to cloud. And when we went to cloud, configuring all of that was easy. How many workers I want, all of that was easy. And you create a cluster and then spin up the cluster. Now, next step forward came elasticity, where I can check I want to have minimum 1 worker. So maximum it can go up to 10 workers. That which is we already have even today also. So I can say auto scaling. So if the load is low, or if you cannot manage with the existing 2 workers, you can add more workers. But I can give a maximum and minimum. So you can go up to 10 workers to use for processing. Auto scaling. So when you run the job, it automatically see based on the data, based on the volume, should I add more workers, or okay, the workers are not being used, the machines are not being used, so I will drop those, to manage the cost. So that is what we have. And then you have different variations of job cluster, all-purpose cluster. Should I bring down the cluster after 10 minutes, 20 minutes if it is not used? Pre-warmed clusters, plot clusters, spot clusters, so many things, so many options were coming in. Each one was giving you more flexibility. Now, the ultimate serverless is that you don't have to worry about anything at all. No cluster, no master, no worker, no minimum, no maximum, nothing. There is a pool of machines, pool of clusters, which are already available, warmed up for you. So you don't have to wait for when you see in the, in your, what you call, the training community edition that you have, every time after 1 hour it goes away, you have to create the compute cluster, right? And then it will take 5 minutes, 10 minutes, whatever, when it comes up, correct?
yes.
Serverless, you don't have to wait. It is already all the servers are up and running or warmed up. It just takes less than 5 seconds, 10 seconds to connect. So that time to warm up, time to create the clusters is gone. The complexity of minimum, maximum, how much time it should be active or should it be continuously active, that is gone. Then based on the cost and the usage, what we do serverless now is everything is simplified. It's given to the Databricks. It will automatically manage the infrastructure. It will give you a pool of clusters, how many machines it has to do, how much time it will take, everything. It will automatically do it for you. And then you pay only for how much processing you have used in the serverless. So your management is gone, your cost management, your efficient, all of that complexity is gone now. So serverless basically means that you don't have to worry about which machines, how many machines, upscaling, downscaling, nothing. Everything will be automatically taken care of for you. It will automatically scale up, down based on your workload. And then once your job is done, it will stop. So you will get charged for whatever you have used. So that is the basically serverless.
So when you create the compute, so we can select the serverless, right?
You don't create a compute at all for serverless. If serverless is already available, when you run the job, you can select serverless. There's no
Okay.
compute to be
So no
created.
need to create the compute as well.
Yeah, yeah. That's the whole point, right? So you automatically get, so this is, serverless they have created.
Yeah. Usually earlier classes we did the compute, right? That's what.
Yeah, that's what I said. So if you go here, when you go, I was talking about, if you go to settings, see here, you can select serverless. That's it, no compute. If you remove this, then.
So this serverless option is available only for the DLT right now?
No, it is not for DLT. It is basically some configuration settings. When you create workspace, it should automatically come serverless.
Okay. So if that is the case,
I don't know
whatever
if
the
it is
job.
community edition. I don't think it is there. For at least premium versions, it will be available. But I think they are also giving some kind of 50% discount for some time to use serverless or something. I was seeing in that one.
Yeah, because when I was trying for this one there to the live streaming, so I selected the node, something is different what you selected. So it was throwing that error, the quota was not there, please request for the quota.
Yes,
So I tried to request the quota to the Microsoft for the Azure people, but it didn't work. So finally I realized that one, okay, I need to select some lower environment node. So when I select the lower environment node, so it was working.
Yeah. So you have set up some quotas for when you set up the account and all of that, right? That's how it's. 1 second, let me see, where is this?
Yeah, that's what I posted that error in our WhatsApp group as well.
Yeah. One second, let me see where that is. Yeah. Yeah, see, serverless compute, hands off, auto optimizing compute, less than 60 seconds startup, versionless with auto update. So if there is no version, they'll automatically update all of that thing. System tables for cost observability, how much it is costing and all of that. Automatic instance type failover, whatever it is. Compute, see, when you do workflows also, you can select compute as serverless and it is enabled when you create these workflows. For notebooks also, you can use serverless here. You can less than 5 seconds startup. So you don't have to wait for the compute to start. Okay, so here you can go and select serverless for Delta Live Table. So basically it is available for, see here, Delta Live Tables, notebooks, and workflows. All of this you can use. Promotional discount for serverless jobs and notebooks until October 31st. 50% discount on all of this. Does not apply to SQL serverless. Automatically and not, so it's not enabled for all customers. Additional steps required by sales or customer to unlock the promotional price, whatever that is. So all of that. Available in all regions and clouds where serverless is enabled. Okay, so that is the serverless thing. But yeah, watch the recording, go through it, start setting up your environment, and get to clone, steps to clone that. I've seen, right? So I will publish this PDF also, and the lab assignment and the Git thing. So everything is there. So you can go through it and start working on it. So by tomorrow, hopefully I should be able to fix this environment, and then we can get started with some more examples. Okay.
Yeah.
Yes, sir.
All right, great. Any other questions?
So apart from that event hub, sir, so do we need to require that ADF or Azure environment for the Databricks?
No, I think that is what we did, but you can also explore other like Kafka, as I said, right? That NASA topic that is coming in Kafka. So we can try that example, but Azure, I think, yeah, that's only for that event hubs that we tried.
Because what I heard from the market, because the Azure ADF is there, right?
Yeah.
So ADF and data lake.
Factory.
Yeah, data factory and data lake storage, right?
Yeah, ADLS.
So yeah, usually files comes there as a central hub for all the environments, and from there depends on that department, or depends on that team will access those files or whatever and use the ADF, and then finally use the Databricks.
Yes.
Yeah, I don't know. That's what I hear.
Yeah. So see, all data coming in data storage files will be on the cloud platform, whether it is S3 or ADLS or whatever. So from there, yes, it can come to S3 will have different buckets, different permissions for different groups. And from there, you start processing using the Databricks environment.
Okay. So do we need to get some knowledge, or do we need to get some things for the ADF and ADLS?
So ADF is different. ADLS, no. ADLS is just like store, just like your Unix, Windows. All there is a file storage. That's it. If you are going for DevOps, or you're going for not DevOps, so admin, right? So you are at Azure admin, account admins, they should know like how to create all of those security and permissions and IAMs for each path. As a data engineer, you should, if you just know at high level, that is good enough. All you need to know is the path, right? How to read from the ADLS path. That's it.
Okay.
Or DBFS path. So when there is ADLS, again, you create an external location within the Databricks mount, or a mount point, or the external location on the mount point, and then use that mount point as a source.
Oh, okay.
Okay, so it's just like Unix or Windows path file where the files are stored. It's the same thing. You're reading from there. Whether it is
and also
ADLS, it's just like external location for you if it is not on the DBFS.
okay. And also, Arun, are you going to teach us once that code layer is ready, right? So it would be accessed by either Power BI, some analytics tool, right? So are you going to show us how reporting tools connects that gold layer and how we can export the data from out of this Databricks?
No, I don't think we would go there because that's completely a different BI. So we are keeping the serving layer ready. It can be, people might be reading from just like another Databricks SQL, right? Just use the SQL Explorer and read from there. We might be using Power BI, using Tableau, am I using Cognos, whatever it is. So what are the downstream systems that are reading can be multiple. We don't have to go to on the other side and see how you read. All you have to do is data is ready in these tables or not. I think that is where we draw the boundary for the. But yes, if you have any if you have any experience or interest in the BI tools, then yes, you can install and get connected and then use that connection to read from this and display the dashboards and all of that. But I don't think we are going there. I mean, as such, within the data engineering, we have so much stuff to cover.
Oh, okay.
So, I mean, nobody will ask you anything about Power BI or anything when you are a data engineer. You just say we serve in the golden gods as
our job is still
sized
we will
views,
that final
and
layer
then it can be anything that is reading from there.
Oh, okay.
Okay.
Yeah. Thank you.
All right, guys. Thank you so much. Appreciate it. I have some action items. I need to update few things, but yeah, please ping me if you have questions. I know last few days or weeks have been a little tied up, but yeah, I'll respond. We'll get connected. Okay.